Hello everyone, in this video we will dive into an intriguing topic that affects us all, chromatography in the food industry, specifically focusing on M&M candies. So this is our group members.
Hello, my name is Anissa Huda. This presentation focuses on the application of chromatography in analyzing the vibrant dyes found in M&M candies. So, chromatography is a versatile and widely used analytical technique that plays a crucial role in various industries, including food science. By leveraging chromatography principles, we can separate, identify, and quantify the different colorants that contribute to the iconic appearance of these popular treats. For your information, the pre-primary colors for mixing dyes are red, yellow, and blue. Other colors are often a mixture of these three colors. So, have you ever wondered how many dyes are used in M&M? Join us as we uncover the colorful world of M&M candies through the lens of chromatography in the next slide. As we know, chromatography is a technique used to separate and analyze components of a mixture. The basic principle involves a stationary phase and a mobile phase. The stationary phase is a solid or liquid supported on a solid, while the mobile phase is a liquid or gas that carries the sample through the stationary phase. The different components of the sample move at different rates due to their varying affinities for the stationary and mobile phase, leading to the separation. In the context of M&M candy, chromatography can be used to identify and quantify the food dyes that give the candies their distinct colors. Here are several of chromatography techniques, which are thin layer chromatography, gas chromatography, liquid chromatography, and lastly paper chromatography. For extracting dyes from candies like M&Ms, a common type of chromatography used is paper chromatography. Paper chromatography is a simple and inexpensive technique that is suitable for separating mixture of colored compounds, making it ideal for analyzing the dyes present in the candies.
Hello everyone, my name is Ivy Grace Lawrence, and now it's my turn to talk about the methodology. And here's the materials needed. The material needed are M&M's candies with various colors, coffee filters or chromatography paper, water, salt, toothpick, dropper, petri dish, ruler, pencil, clips or tabs, and beaker. Now let us move to the methodology to conduct chromatography experiment. Firstly, we need to prepare the chromatography solvents, and in this step, we need to measure 3 cups of water and add 1 per 8 teaspoon of salt to the water. Next, stir or shake the mixture until the salt is completely dissolved. Pour about 100 ml of the salt water solution into a beaker. Next, prepare the chromatography paper. We need to cut 2 pieces of chromatography paper, and by using a pencil, draw a horizontal line 1 cm from the bottom of each paper strip. And then label one strip for Skittles and one for M&M's candies. Now, after we are done preparing the chromatography solvents and chromatography paper, sort the candies, sort through the M&M's and Skittles to find candies that have matching colors, and then dissolve the M&M's coloring by using droppers to place a single drop of water for each N&N's colors on the bottom of the petri dish, and then make sure the drops are evenly spaced. And then place an NMNs on each water drop and let it sit for 1 to 2 minutes to allow the coloring to dissolve into the water. Next, remove the NMNs candies from the petri dish. Right, we also need to dissolve the Skittles coloring by repeating the same step we used to dissolve the NMN's colorings, which is step 4, but this time we use the lid of the petri dish by using the dropper to place a single drop of water for each Skittles colors on the lid, and then place a Skittles candy on each water drop and let it sit for 1 to 2 minutes, and then remove the Skittles candy from the lid. And then how to apply the dye to the chromatography paper. To apply the dye to the chromatography paper, we need to dip the end of the toothpick into one of the colored water droplets, and then apply the colored solutions to the origin line on the corresponding label chromatography paper, either NNNs or Skittles. and then apply 2 to 3 coats and let each coat dry between applications, and then use a clean toothpick for each color and repeat the process. Now here's how to set up the chromatography experiment. Firstly, tap or clip the papers side by side to a pencil or ruler, but please make sure it's not touching. And then place the pencil or ruler over the mouth of the beaker so that the bottom of the chromatography paper barely touch the saltwater solutions in the beaker. And please ensure the papers are not submerged beyond the origin line. Here's next how to develop the chromatogram. And to develop the chromatogram, we need to allow the salt water to travel up the paper by capillary actions, which carrying the dye component with it. And then, when the water nears the top of the paper, carefully remove the papers from the beaker. And this step may take about 10 to 20 minutes. And next, place the paper on a clean, dry, flat surface and let them dry completely. Alright, we have reached to the last step, which is analyze the results. To analyze the result, we have to observe the separated dye bands on the dried paper strips, where each band represents a different component of the candy dye. And then measure the distance traveled by each dye components from the origin line to the center of the band.
So this is the example of result where we use blue, green, orange, yellow, and brown M&M's candy. As we can see here, the blue up here, green is really faint, yellow has a big spot right here. So now we go back to the green. As we can see, there's a spot here which coincide with the yellow, and there's another faint spot here coincide with blue. So that tells us that green is made up of blue and yellow color. Orange is a spot right here. Now we look at brown. Brown got that yellow, blue, orange, and red, which of course we didn't do, so it's like brown is made up of all the colors. So hi everyone, today I will take you through the fascinating world of chromatography and its critical application in the food industry. We'll explore how this powerful technique helps maintain the quality, safety, and authenticity of the foods we consume. So basically, as we know, chromatography is an analytical technique used to separate, identify, and quantify components in a mixture. In the food industry, it's a key tool for ensuring our food is safe, nutritious, and genuine. So, first of all, one of the essential uses of chromatography in the food industry is the detection of the pesticide residues. High performance liquid chromatography, or we call it as HPLC, is particularly effective here. HPLC can detect and quantify pesticide residues in fruits and vegetables. For instance, it might reveal the presence of organophosphate or carbamates, ensuring these chemicals are below the maximum residual limits set by regulatory agencies. Next, we have the gas chromatography mass spectrometry, or GCMS. This method is used to analyze artificial sweeteners, preservatives, and flavoring agents in the beverages and processed foods. So, for example, GCMS can identify and quantify aspartame and benzoates in soft drinks, ensuring that these additives are present in safe level. Then we have ion chromatography, or IC. It's invaluable for measuring the nutritional content of food products. It accurately measures the level of vitamin and minerals. So, for example, IC can determine the concentration of vitamin C in fruit juices or the calcium content in dairy products, providing precise nutritional information. Next, we have liquid chromatography mass spectrometry, or LC-MS-MS, is crucial for monitoring contaminants. This technique detects harmful substances like mycotoxins in grains and nuts. LC-MS-MS can identify aflatoxins in peanuts, ensuring they meet safety standards. So, to wrap all of this, chromatography stands as a cornerstone in the food industry, ensuring that the food we consume are safe, high quality, and authentic. Through all of these techniques, we can detect pesticide residues, analyze food additives, determine nutritional content, monitor contaminants, authenticate products, and analyze flavor compounds. These powerful analytical methods help maintain stringent food safety standards, enhance the nutritional accuracy, and verify the authenticity of various food products, from ensuring that the food and vegetable are free from harmful pesticide residues to identifying the precise mix of flavors in gourmet chocolates. Chromatography plays an indispensable role in every aspect of food food production and quality control. So, as we continue to innovate and refine these techniques, the future of chromatography promises even greater advancement in food safety and quality. Thank you for your attention and interest in this critical field. Together, we can continue to promote safer and more enjoyable food experience for everyone.